All right, so today we are going to continue with our equivalent expressions. So you're going to learn how to almost undo the distributive properties. So if you remember on the last couple of lessons, you worked on distributing. So for instance, if I had an expression that's had 2 parentheses 4 plus 7x, well, we would distribute in. So we do 2 times 4 and we'd get 8. And we distribute that 2 to the other term and get 14x. Well, now we're going to go backwards. So we're going to start where it looks like this and back out to our equivalent expression. So it's factoring out. So if you're good with your multiplication and division facts, this will be easier. If you struggle with your facts, you can maybe use a multiplication chart to help you along. So the directions are very simple. We are generating equivalent expressions by factoring using the distributive property. And if you remember the term factor, 2 factors multiply together to get a product. When we talk about factor pairs, 2 numbers multiplied together to also get a product or a bigger number. We talk about factor trees to find prime factorization. You remember doing that to find the GCF or greatest common factor. So sometimes we will find greatest common factor and sometimes common factor, but the way this works is pretty simple. So if I'm looking at the expression in the yellow posted here, I have this term 7b and this term negative 14. We'll just worry about that negative sign, just like subtraction. So I look, well, I see a 7 and I see a 14. So I'm thinking, well, what are the factors of 7? My factors of 7. So this is in my head. So I'm thinking 1 times 7. And then the factors of 14 are 1 times 14 and 2 times 7. Now factoring out a 1 doesn't change anything, so we don't really use that. And we also have the b in there. We'll talk about that in a minute. All right, so I'm looking and I see my common factor of 7. So that's the number I will factor out. So I'm going to say, well, I'm going to divide both terms here and here by 7. So if I pull that out, I end up with a 7. Well, 7 right here divided by 7 gives me 1b. And then here, that's a 1. 7, so 14 divided by 7 gives me a 2. So an equivalent expression, these two are equal or equivalent. So now, in algebra terms, we don't need to write the coefficient of 1 in front. So I could also write it 7 times. Here still is 1b, that's 1b, minus 2. Okay? If I want to check it, well, we could check it. Let's try to check it. Let's try to distribute this back. 7 times b, I get 7b, minus 7 times 2, 14. What do you know? It's back where we started. There we go. Here we go around again. Perfect. Distributive property. We factored out. Let's try another example. Okay. Generate, same directions. What do you know? I'm going to switch colors. Let's see. We'll go with, I don't know what that is, orangey. So looking at this, I don't know about that color, but we'll try. Looking at these two terms, I have 3y and I have 9. Well, I'm thinking, well, there's no y in both. There's no 3 in both, but a 3 is a factor of 9. So I said, well, let me try to divide both terms by 3. Now, I don't have to write that. That's what I'm thinking in my head. And I'm saying, well, my factors of 3 are 1 times 3. My factors of 9. You don't have to write this out, but if it helps you, of course, you can always write things out. I'm going to use a dot this time just to show you that sometimes multiplication is a dot, sometimes it's an x. Okay, so I'm going to pick a common factor of 3. That's common to these two terms. In algebra, we call those terms. You remember that from early on. Okay, so I will factor out or divide both sides by 3. Well, if I take this first term and I do 3 divided by 3, I'm left with 1y. I'm going to get rid of that 1. There it is, 1y. Plus 9, I'm going to divide this in my head by 3. 9 divided by 3, I get 3. And there we have an equivalent expression. Let's try to test it, see if we did it work. Did it work? Is that even right? Oh my goodness, quarantine brain here. See if we did it right to see if it worked. There you go. 3 times y, I get 3y. I don't know. 3 times 3, I get 9. My plus sign, there we go. They are indeed equivalent expressions. So far, so good. Let's try another example. Ooh, this one looks a little different, not just because it's in blue. So I'm thinking of my two terms. Here's my first term here and my second term here. If you notice when I identify a term, I include the operation in front of it. In this case, a minus sign or a negative sign, -9. We include that with the term. You'll talk about that later when you combine like terms. That's a little foreshadowing for you. You can use that for your ELA homework. All right, so 6m minus 9. So I think of my common factors. Well, 6 does not have a factor, is not a factor of 9, and 9 is not a factor of 6. Can't be, it's bigger. All right, so 1 times 6, 2 times 3. 1 times 9, 3 times 3. In this case, my common factor is 3. So I'm going to divide both of these terms by 3. Divide by 3, divide by 3. 6 divided by 3, right here. I'm left with 2m. I forgot to pull out my 3. There it is, 3 times 2m. 3 divided by 3 is 3. So my equivalent expression is 3 times the 2m minus 3. So there we go. It's a nice equivalent expression. Let's test it. I'm going to test it using a different color here. 3 times 2, I get 6m. Minus 3 times 3, I get 9. What do you know? Here we go, right where we started. That's pretty sweet stuff. All right, let's try another one. Here we go. 27 plus 9d. I picked the number 27 because that's my son Danny's hockey number. So 27 plus 9d. There we go. We're going to generate an equivalent expression by factoring using the distributive property. That's our plan. So, well, I always like to look and say, well, there's no d for both terms, so we can't factor that out. We will get to variables, another bit of foreshadowing for you. So if I'm looking, I have, well, I ask myself, here's my term. Is 9 a factor of 27? Beautiful, it is. So I can divide both terms. You can't even see the division sign. Divide both terms by 9. 27 divided by 9. So let's pull it out. I divide by 9. So, and then I could also think backwards because multiplication sometimes works better in people's heads. Once you divide by 9, 9 times what is your 27? There's your 3. 9 times what gives you d? That's a little weird, but it's a d. If you feel better with the 1 in front, you can do that. Now let's test it. I like to test showing you a different color. So 9 times 3, 27, plus 9 times d, 9d. Not 90, 9d. So there we go. Another example. Not too hard. All right. 6 plus 12w. Now, let me show you a couple things on this one. This one's a little different because if we look at our factors of 6 and 12, well, 6 is 1 times 6, 2 times 3, and 12 is 1 times 12, 2 times 6, and 3 times 4. So when we get to this one, well, look what happens. We have a 6 that's common, a 2 that's common, and a 3 that's common. So in this particular case, we could make 3 different equivalent expressions. Am I going to fit it? No, I don't know. Expressions. And that's where it gets a little tougher. The good thing is, if you know you could factor out a 6, you can factor out a 2, you can factor out a 3, whatever. I'm going to start with the lowest one, so I'm going to factor out a 2. I'm going to divide both terms by 2. So 6 divided by 2, I get 3. 12 divided by 2, I get 6w. There's one equivalent expression. Let's try another one with a different color, orange. Aren't you glad I picked that color? Now in this case, I'm going to factor out a 3. Well, I'm going to switch colors, so 3. 6 divided by 3, I get 2. 12 divided by 3, I get 4w. Oops, I forgot my parentheses up top. That's a common mistake. I do that often. My brain's shot sometimes. The last one is the 6. I could divide both terms by 6. I'm going to show that over here. Divide by 6. This is tricky now. 6 divided by 6, I need to put a 1 in there. I need that. 12 divided by 6, and there's my 2w. All 3 of these are equivalent expressions. So this is equivalent to all of that. Ooh, right there. All equivalent. Neat stuff. Who'd have thought you would do this in 6th grade? Nice work. All right, now this one, I have 9f minus 11f. I don't know, maybe the f is French fries. 9 French fries minus 11 French fries. Can't do that in real life because, you'd have negative French fries. I don't really know how that would happen. Now, if I'm thinking of my factors of 9 and 11, well, I know 11 is prime, so it's just 1 times 11. 9 is 1 times 9, and some kids think it's prime, but we forget about 3 times 3. There's nothing common other than the 1. That doesn't help us. But each term has an f. So this one's weird. We factor out the f. Look at what we're left with. 9 minus 11. There we go. Simple. That one looked harder than it is. Fantastic. F for fantastic. All right. This one, 8x plus 16. I was going to show you this, but I'm going to skip this one because it's similar. I'm going to do one example. Look at this. 8 in my head. 1x plus 2. I'm not going to show math. I'm going to do some options in my head. I'm actually not going to skip this. So 8, I could divide them both by 4. 4 times what gives you 8? I get a 2. 4 times what gives you 16? I get 4. Well, let's see. They're even, so I could divide or factor out a 2. Then I think to myself, 2 times what gives me that? 2 times 4x gives me 8x. Plus 2 times 8. So I was going to skip it, but look at that. Pretty quick. Beautiful. I had a kid 1 year who always factor out fractions. If you want to challenge yourself, try that. All right, last one. 10k, so go running when you're done, plus 30k. Well, I'm going to start with the funny one. I'm going to start with the k. K, 10 plus 30. Done. Well, I could factor out a 10. I see a 10 in that term. I see a 10 in that term. 10 times k plus 3k. I don't know. I've never heard of a 3k race. I should have made it 50, so it was a 5k race. Here's one other thing I want to show you. I could factor out the k as well, like this. 10k. Well, that first term is 10k, so I'm left with 1 plus 3. So we could do that as well. You may see that sometimes. There are others. I can also factor out a 5. I could factor out a 2. Okay, so that is basically how we are going to work with the distributive property. All right, so let's hope that made sense. We'll do some examples and go from there.